Okay, welcome to 5.4 Logarithmic Functions. Just use this first slide here to kind of go back and see what you're doing, but you don't really need it. What you need is this right here. The base, the base in the logarithm is also the base under your exponent, okay? And the exponent happens to be the answer of the logarithm. All right, you can think of it like this. A to y is to x is equal to x. All right, it's kind of a circular thing. Obviously, if the y was over here, then you'd go this direction. A is to y, as y is to x. Just depends on where it's at. You just do a circle to the answer, but just remember that the base is also your base. So if you had to write this as a logarithm, the base goes in the base position, and the exponent is your answer. So you may have to come back to the slide to begin. All right, let's start. All right, change the logarithmic form. Okay, so we're just going backwards. So notice the base here. So that's going to be 1a is log base 4. And the answer is always what you're taking the log of. Log base 4 of 64 is equal to the exponent, 3. All right? All right, so now part B, again, the base, log base 4 of 1/64th, the answer is always equal to the exponent, -3. And C, the base is t, okay, so log base t of the answer, s, is equal to the exponent, r. And D, that's our base, so log base 3 is of 4 minus t, so let's make sure it's a group there, is equal to the exponent. Exponent's always the answer, okay? Now E, the base is 5, log base 5 of the whole thing here, a plus b over c, is equal to my exponent, 7t. And then F, you do it, and then come back to this. Log of 0.7, okay, of 5.3 is equal to the exponent t. All right, change to exponential form. Remember what I said, the base is your base. So 3a, that's our base, to the exponent is equal to 32. And you can check it. 2 to the 5th, 2 times 2 times 2 times 2 times 2 is 32. All right, b, our base, 3, raised to the exponent. Remember, your exponent's always your answer. And that's equal to 1 over 243. So that negative exponent there puts this in the denominator. So 1 over 3 to the 5th is going to give you 1 over 2 to the 43rd. C, base t raised to p equals r. And D, base 3 raised to 5 is equal to x plus 2. E, base 2 raised to 3x plus 4 is equal to m. And part F, base b raised to the 3/2 power is equal to 512. So you're learning manipulation at this point. We haven't solved anything yet. We're manipulating. Now, solve for t. All right, using logarithms with base a. Okay, if we're using logarithms and this is my base, okay, a is the base, not 2a. It would be 2 with parentheses 2a, the whole thing raised to 2 over 3 if you wanted 2a to be your base. Okay, but 2a is not the base. It's just a. Okay, so what do we do with the 2? Well, let's divide off the 2. We'll learn what to do with it at another time. So we have a to the t over 3 equals 5/2. If we change this to a logarithm, That's our base. So log base A of the answer, 5/2, is equal to t over 3. Okay, so we're supposed to solve for t, so we're going to multiply by 3 on both sides. Okay, and now t is equal to 3 log base A of 5/2. Okay, and that'd be the answer. You can't solve it because you have two variables, remember, but we solved for t. We can't get an actual answer unless we knew t or a. Okay, next one, we got to get t by itself, so we're going to subtract h. So k minus h equals, don't drop the negative. Okay, we're going to divide off a negative c. Okay, so now k minus h over negative c is equal to a to the t. And so now that's our base, so we can say, I'm just going to flip-flop these. Log base a of the answer, k minus h over negative c, is equal to the exponent. The exponent's always the answer. Okay, so subtract d, a minus d. We're just doing algebra here until we get to the end. We're always trying to get the base and the exponent by itself if you're trying to change to a logarithm versus an exponential function. So this is exponential. We're changing to logarithm. So now divide by b, just manipulating. So a minus d over b is equal to a to the ct. Okay, so now we have the exponential by itself. So again, I'm just going to flip-flop it. Log base a of our answer, a minus d over b, okay, is equal to the exponent, ct. Now we got to get t by itself, so let's divide everything by c. Okay, and that would be our answer. Crazy. And if we wanted to make it look a little nicer, because you really shouldn't leave it looking like this, this is the same thing as a 1 out in front. We could just say 1 over c log base a of a minus d over b. That's the same thing, and actually that's probably a little neater to write this as the answer. That's probably what they have in the back of the book. Okay, number 11. So change all these to logarithmic form. All right, so the same type of thing. Okay, it doesn't say solve, just says change it. So that's our base. So log base 10. You don't have to write 10 if you don't write the 10. If you don't write a number there, it's base 10. Just like when we say square root, we don't ever write the 2 up there. If there's not anything there, we know it's a square root. So it's understood if there's no number written here that it is base 10. So whenever I leave it empty, that means it's base 10. So base 10, and our answer always goes here, and the exponent is always what we set it equal to. Okay? And b, the base is 10 again. We're over here. And the answer always goes here. 0.001 is equal to the exponent. Okay, and c, log base 10 again of y minus 3, put parentheses around it, it's a group, is equal to the exponent x. And d, base e, that's natural log. All right, so anytime you say log base e, that's the same thing as just saying natural log. Okay, so whenever you see ln, your base is e. So natural log of the answer is equal to the exponent. And e, again, we have natural log of 3 minus x, that's a group, is equal to 2t. And now we have to divide by 2, or like I said in the last problem, let's multiply by 1/2 on both sides. And we have 1/2 natural log 3 minus x equals t. Excellent. All right, change to exponential form, going back the other way. So a, our base is 10. Notice there's no base written here, so 10 raised to the 50th power is equal to x. Part b, listen over here, base 10 raised to the 20t is equal to x. And C, natural log. So e raised to 0.1 is equal to x. And then D, e raised to the group 4 plus 3x is equal to w. And e raised to the 1/6 is equal to z minus 2. Awesome. All right, now find the number if possible. All right, so let's just talk about this. So the log of any base, what does that equal? Well, let's change it to exponential function. 5 to the 0. We don't know what it's equal to, so obviously it's equal to 0. There's nothing on the other side. Okay, or let's just say this. Let's say we didn't know that. Okay, let's say it's x. I don't know what it's equal to. So 5 to the x is equal to 1. We changed it to exponential. Well, what does x have to be for any base to be equal to 1? So x have to be 0. So the log of any base of 1 is always going to be 0. That's going to be your answer. All right, B, what does this mean? Let's check this out. Log base 3 of 3 equals x. Well, we don't know what it equals. That's why I said x. So 3 to the x is equal to 3. So when their bases are the same, the exponents must be the same. There's a 1 on that 3, so x equals 1. That whole thing's equal to 1. C, okay, let's set it equal to x. Log base 4 of negative 2 is equal to x. So 4 to the x is equal to negative 2. How do we get that? So now we have x there. So we look at this, and we have an exponential equal to a negative. You can't take an even problem and raise it to any power to make it negative. So it can't happen. So this is not possible. Okay, now D. All right. D is a lot like B, so I want to use these two to help you understand something. So we have the log base 7 of 7 squared is equal to some answer. So the base to x, 7 to x, is equal to 7 squared. The bases are the same, so x is equal to the exponent. Well, on B, wasn't 1 our exponent on this answer? So if the base and the answer's base are the same, just like on B and D, then the answer should be the exponent. All right, that's a shortcut. E. Oh my, what does this equal? So 3 log base 3 of 8 is equal to x. I don't know what it equals to. Okay, so if we're going to change this to a logarithm, because this is exponential, just because you have a log in the exponent doesn't mean it's a logarithm, okay? The exponent is a logarithm, but the whole problem is exponential. So the base becomes my base, the answer goes here, and the exponent goes here. And if you have the same logarithm on the same side, then their answers, or what you're taking the logarithm of, have to be the same. Okay, so the answer is 8. So here's the shortcut. If this and the base of the logarithm and the exponent are the same, then the answer is just what you're taking the log of. All right, so F. So there's different ways we could do this. So 5 to the x is equal to 125. Well, the bases need to be the same, so 5 to the x is equal to 5 cubed. 5 cubed is 125, so x is 3. And let's do G down here, okay? Log base 4 of 1 over 16 equals x. The whole point is that we try to make our bases, these two, the same, but we'll do that at another time shortly. So 4 to the x is equal to 1 over 16. Okay, 16 is in the denominator, so we could do 1 over 4 squared. How do we get 4 in the denominator? By making your exponent negative. So 4 to the x, okay, is the same thing as 4 to, if x is negative 2, okay, won't that be the same as 1 over 4 squared? So x would have to be negative 2. Okay, and the correct way of saying this is 4 to the negative x. That gets you down to 4 to the x, which would then equal 4 to the 2. So x is 2. Okay, but we have a negative in front of it. That's what got you there. So it had to be negative 2. All right. All right, find the number. Now the opposite. Let's just try to understand something. The shortcuts. If the base and the base of the exponential logarithm are the same, then the answer is 3. So we explained this in the last couple problems. Again, if your base of your logarithm matches the base of what you're taking the logarithm of, then the answer is the exponent. Again, let's just explain it just to help you out here. Log base 10 of 10 to the 5th is equal to some number. Change it to exponential. The base raised to the answer is equal to what you're taking the logarithm of. So if the bases are the same, it's the exponent that is the answer. All right, see? Now you have log base 10 of 100, but that's the same thing as log base 10 of 10 squared. 10 squared is 100, and now those are the same. The answer is 2. D, log base 10 of 0.0001. Well, what's 0.0001? That's 1,000th, 1,000th. So let's rewrite it. Log base 10 of 1 over 1,000. That's 1,000th, okay? No, 10,000, sorry. Tenths, hundreds, thousands, 10,000ths. So 10,000, 1,000 is 10 cubed. 10 times 10 is 100. Times 10 is 1,000. Times 10 is 10,000. So this is log base 10 of 10 to the negative 4. The negative puts it back in the denominator. 10 to the 4th is 10,000. And so now, since those are the same, the answer is negative 4. Okay? So those are our answers. Let's go to E. And now we have a logarithm in our numerator, in our exponent position. Okay, so let's change this to understand that when you have like bases and you multiply them, you add the exponents. So let's change this to 10 to the first times 10 to the log base 10 of 3. So remember, like bases, when you multiply with like bases, you add the exponents. So this is the same thing as this up here. Well, 10 to the first is 10. And then you have 10 log base 10 to the third. So then if the base and the log of 10 is the same, then that's 3. And so 30 equals x. All right, so natural log is the same thing as your logarithm. So logarithm is base 10, natural log is base e. So on A here, we have e log base e of 2. If that's how you want to think of it, that's okay. You can rewrite it. So the answer here is just going to be 2. For B, again, that's base e. So if those are the same, then that's negative 3. And C, we have addition in an exponent, so separate it and make it multiplication of the same base. And so we have e squared here. And the natural log again is base e. So since those are the same, that's 3. So we would write this as 3e squared. All right, now solve the equation here. If the base logs are the same, then x plus 10 must equal the 8 minus x. So add x, and 2x plus 10 is equal to 8. Subtract 10, and 2x equals negative 2. Divide off the 2, x equals -1. So think about it, if x is -1, that's log base 4 of 9. If that's -1, then it's 8 plus 1 is 9. So those are the same. Same thing here. Going a little bit faster, the bases are the same, so x minus 2 has to be equal to the 3x plus 7. Okay, so let's subtract x. And -2 equals 2x plus 7. Don't drop that minus sign on the 2. It's -2. And let's subtract 7. That's -9 equals 2x. Divide off the 2. So -9 halves is equal to x. All right, these are both base 10s, remember? So that means x squared is equal to minus 3x minus 2. And so now you have a trinomial. So x squared plus 3x plus 2 equals 0. So I added those to the other side. And that's x plus 2, x plus 1. So the answers are -2 and -1. And log base 3. So change it to exponential. 3 squared equals the x minus 4. So 9 equals x minus 4. Add the 4. X equals 13. Again, 9 to the -3 halves. Now you have as equals x, but now we have a root. So that's the square root of 9 to the -3. Let's put the -3 outside. So the square root of 9 to the -3. That's 3 to the -3. So the negative puts it in your denominator. 3 cubed is 27. So x is 1 over 27. And e to the -2 equals x squared. Okay. So 1 over e squared equals x squared. Take the square root on both sides. X equals 1 over e plus or minus 1 over e. Okay, so this is an exponential. It's e to something, so it's exponential. So the natural log of the same base of what it's equal to is equal to the natural log, or excuse me, the exponent. Okay, so these are all the same bases here, except you have this 2 times this here. So if we divide by 2, we're going to have, let's use our calculator and do the natural log of 9 is 2.19722 divided by 2, okay, and it's 1.0986 ... That equals the natural log of x, okay? So if we raise e to that value, we get 3 equals x. Last one. Same thing here. Make it a natural log of, that's your base, of 27 is equal to x times the natural log of 3. Okay, again, we could divide off the natural log of 3, and that's what x equals. All right, so these are the same bases here. So if we do the natural log of 27, you get 3.295 ... divided by the natural log of 3, and you get 3. Okay, so if you do it on your calculator, as long as you don't round up, if you leave the long numbers in your calculator, it will give you the exact answer of 3. All right, good job.